Welcome to episode 120 of ArrayCast. I'm your host, Connor, and today with us we have a special guest who I guess we will introduce in a moment just after we have Adam give his brief introduction.
Well, I'm Adam Brodzewski. I do APL at Dialog. I'm generally interested in array languages, though.
And as mentioned before, my name's Connor, host of ArrayCast. Bob can't fix it in post. A massive fan of all the array languages, and typically we do announcements before we introduce the guest, but it's a bit odd seeing as we have Jacob with us live on screen on YouTube. If you're not watching this, or should say listening to this in an audio podcast app. So Jacob Lockwood, we don't know much about him yet, but we do know that he is the author of Fix APL, and he's, I think for both Adam and I, a couple decades younger than both of us. Quite amazing that you are the author of this APL, and you were brought on to our radar, or at least my radar, last episode when we were just Adam and I talking in episode 119. I believe it was Madeline in the YouTube chat, which is one of the great things about the fact that we are now live on YouTube. We can interact more with the listeners, at least that are live. And Madeline mentioned when we were having the conversation about the learnability of languages, the number of primitives, and ambivalence, she mentioned offhandedly, you should check out Fix APL, which I was like, I've never heard of this, and I'm live on a podcast right now. I don't have time to go check this out. And sure enough, when the podcast ended, I went and checked it out, and I said, holy smokes, how come I have not heard of this? And so I think that's what we're going to talk about today. But before we do that, we're going to do a couple announcements, and then we're going to ask you, Jacob, about how you got into computing, how you got into array languages, and then we're going to spend the rest of the episode talking about Fix APL. So I think first Adam has a couple announcements, and then we'll get into questions with you, Jacob.
Sounds good.
Right. So two things, both sort of competition related. We just launched a new round of the APL challenge, which is this very basic introduction to APL where you can also win some small prizes, but it gives you all you need to learn in order to complete the whole thing. I rewrote the whole system from scratch because the old one was getting a bit long in the tooth, and I'm really happy about how it turned out. And you've got dark mode. So go check that out at challenge.dialog.com. And then we made a modification also to the APL Forge. So that's sort of a longer term. It's a once a year thing. The Dialog will give out some larger prizes and opportunity to come and present your work at the Dialog user meeting. This is our yearly, yearly conference. And so until now, it has been only for projects where APL was the core of the algorithm of the system. But we thought we'd expand that a bit. So if you want to write a tool or create a tool somehow that does not use APL as its core technology, but provides some sort of quality of life improvements or help for people that are writing APL, then that's also eligible. So as an example, something that could have been obviously not eligible to win a prize, but like I created Applet, which is this lookup table of APL phrases, but it's actually written in HTML, CSS, JavaScript, not in APL. It's just the content that it serves as APL. So that's a tool that's not an APL tool, but it helps APLers. So if you have a tool like that that's not written in APL, say like Connor's ArrayBox, then that would be potentially eligible for a prize in the APL Forge. So you can check that out at forge.dialog.com.
Awesome. Links, as always, will be in both the description of the YouTube video and the show notes of the podcast and our beautiful new website, arraycast.com. I guess same domain, but new, beautiful design. And with the announcements out of the way, it is a huge, excitement. I'm very excited to talk to you, Jacob, about Fix APL. But before we talk about Fix APL, I'd say take us back to the beginning, but the beginning for you wasn't that long ago. So take us back however many years it was that you started getting into computing or programming, and then tell us about your path from there to how you discovered array languages, and then we'll get to Fix APL.
Okay, sure, yeah. So I started coding in 2020 when I was, I guess, 11 or 12, maybe 13. I don't remember. Somehow, wow. I don't know why I can't think of.
I mean, it was COVID times, right? So
Yeah,
that era is
it
like a
was
blur
so
for all of us.
disorienting. But however many years ago it was, I was kind of stuck at home, doing Zoom middle school, and I really didn't have much going on. I looked up how did they make Minecraft, and it said Java, and so I learned JavaScript, of course, and I thought it was interesting. I had some, little iPad app where you could put in HTML and JavaScript, and it was terrible. There were ads all over it, but eventually I got a laptop, and around the same time I got into Code Golf through the Code Golf Stack Exchange website, and that was really how I got into a lot of more esoteric languages. Like I started with JavaScript, and then I got into some of the languages designed for Code Golf, and eventually I found, I mean, I had known about array languages for a little while at that point, but I started trying out J for a little while, and I thought it was very interesting. I had really no idea what it was used for or much about the other array languages, but I tried it out. I thought trains were cool, but they were too confusing for me, and so I kind of just gave up. Then later I tried Uiua, and that was actually the first array language that I seriously tried to learn. And I got really into that. I still am very into it. And from there, I started learning more about other array languages. BQN, APL, Tiny APL actually was the first non-Uiua array language I really picked up, which is kind of funny. But eventually I was already sort of interested in language design at the time because a lot of the Code Golf community is interested in that kind of thing. And I had done some little language design experiments in the past, but Fix APL was really my first serious programming language project. And I did it in July, June of last year. And I had summer break, so I kind of just spent all day, every day working on it until I got it to how it is now.
So let's. I want to go back because I'm very curious about the path to Fix APL and the influences and the things that you liked in different languages. So you said that you were playing around with Code Golf languages before you kind of hit J and then Uiua and then Tiny Apple. Were those because I know of Jelly and I know of Vixel, I think is the name when we talked about Jelly on ArrayCast. Are those the ones, or is there like a whole collection? Because I'm sure there's a world of golfing languages that I'm not familiar with.
Yeah, I mean, there are more. I never really picked up Jelly, honestly. I quite liked it, but it seemed too complicated for me to really understand. I did try Vixel, which I thought was interesting. And that maybe made it easier for me to get into Uiua because Vixel is stack-based. There were some other ones. There's one called Japt, which is basically JavaScript with a bunch of little shortcuts and just, golf your syntax. You don't need parentheses and things. There were a couple others. I'm trying to think. I don't know. But it was kind of mostly those, I guess.
Okay.
And that's, yeah.
And so from there you went to J. What are your thoughts about, I mean, you already said that you found trains confusing, but overall, like having programmed in a couple different languages, JavaScript and then the code golfing ones, what were your thoughts? Because clearly, like you got into, array languages. Was it Uiua was the one that you really kind of sold you on the paradigm, or was it J that piqued your interest, but then you found Uiua because it's all in the same family? Like, what was your path to deciding that you wanted to write one for yourself?
Well, I found J mostly just because I knew some people who were talking about it, and I did really find it interesting, but I didn't totally understand arrays, how they worked with multiple dimensions, and also the syntax I thought was confusing, but it wasn't as scary to me because I'd already tried some of these code golf languages. But when I tried Uiua, that was when I really seriously got into the array paradigm, I would say, yeah. That was definitely what sold me. Then from there to making a programming language myself, I'm not sure. I guess I started using Tiny APL and then BQN and some other array languages, and I did find those very interesting. I really liked the way APL works, just the infix nature of it. It made me realize, I guess, how different Uiua really is to those. And as I was using them, I guess I sort of realized that I kind of missed some of the things about Uiua when I was using APL. Like, different things, but especially ambivalence was just something that I really found confusing, how different functions had different behaviors with different numbers of arguments, and especially the way it played into trains, how when you write a train, you actually don't know what it means until it's applied, because it can have either a monadic or a dyadic form, which are totally different. And I knew a little bit about fixed arity from looking at Jelly and Uiua, of course. And I was thinking about it, and I realized that if you did have an APL with fixed arity, you could do some very interesting stuff with trains and modifiers, similar to what Uiua does. And I sort of just got into it from there.
I mean, that is it's very, very interesting because as the viewer on YouTube can see, we're staring at the character set of Fix APL, and I gotta say, I mean, we're talking about Fix APL and your design choices, but they align very closely with like a lot of stuff. Like, I'll be honest, the BQN character set, I always miss the APL glyphs a lot of the time, especially iota. Which it just warms my heart to see iota back. Iota's back,
We do
folks.
have a couple of similar ones. Yeah, iota. We've got the selfie. Trying to think what else is missing.
You've got the rotate, which I guess technically BQN still has that one. But there, in general, though, I like this. And you brought back a Valin format, which are sorely missed.
Yes.
In BQN. So, anyways. It's a lot of the stuff that I really like that you've kind of, it's a hybrid, probably, I'm not sure if you would agree, and maybe Adam, you can weigh in on this. Like this seems like the most hybrid, inspired by different language. Like you can see the influence from Uiua in that there's no ambivalence, and also too, like you have the same
with like length and shape.
Yeah, there's characters influences. There's also the fact that you can now color these, a monadic color and a dyadic color, and there's the transpose glyph. So like there's a ton of Uiua influence. At the same time, there's influences from APL and BQN. Like you can see BQN glyphs in there as well. And sometimes they're repurposed for other things. Like I think reverse uses the box glyph or pair glyph from BQN. Although I'm not sure, maybe that's also in Uiua. So you maybe can tell us. It's the bow tie.
No, in Uiua it's something else. Yeah. I mean, the bow tie.
I like a lot of this.
Thank you.
So I guess all to say that I love a lot of the influences. Oh yeah, table is another one you've borrowed. Like so that's the thing. It's like it's got iota from APL. It's got table from Uiua. I mean, was Uiua the first or was it Tiny Apple? I don't actually know. What language was the first one to introduce the table outer product?
Having a dedicated outer product symbol in an APL, not in J, has been a long time wish for many people because it has this anomalous syntax in APL. I mean, it has reason historical reason, but today it doesn't make much sense anymore.
Sorry, what you
So
said? A
that
dedicated what glyph?
so an outer product glyph
Oh,
does
outer
not
product
exist in
glyph. Gotcha.
APL
Yes.
in traditional APLs, right? The syntax we have for outer product does have some amount of sense in a historical context. But in today's world, it doesn't really fit in so well.
Yeah.
And it's actually the jot that's the problem, more than the syntax itself. So
Yeah.
so that symbol there is an obvious symbol for table, right? It looks like
Yeah.
a
Yeah.
table.
It
That's
looks
one of
like
the
a
symbols that has
table.
been that has been discussed for many years. If you were to add a symbol, what would you add?
Yeah.
I even discussed it with Roger Huey. Why don't we have a or normalize the syntax like that? I even suggested that dyadic scan, like function backslash, doesn't have a dyadic form in dialog API. And I even suggested that we could just overload that to be the table, because it sort of shows that they can understand that the backslash is sort of the diagonal going down. If you were to do it like an equality on a iota sequence, you'd get the diagonal down with ones. That's sort of an outer producty thing. A little bit of a stretch.
Yeah.
And he said we don't need a symbol for outer products. We already got one, the rank operator. Which is you can then ponder on that.
Yeah, I mean it's I should make a YouTube video on the what do you call it? Non-uniformity of outer product. Like if you go to the Omnibar, it's like the most different glyphs. Cap has a different glyph, right? It's the quad jot, and then we've got table, we've got APL's outer product, we've got BQN's little, I don't even know what you call that. But oh yeah, look at this. We can even look at it. The beauty of like this one, probably it's got the most what do you call it? Yeah, non-uniformity, number of different glyphs. Look at that. It's even got the target, which is from Zyma APL. I had no idea.
I guess so, yeah.
But anyways, it's fascinating that there's so many, because most languages or most glyphs doesn't have this many different symbols for it, right? Anyway, so it's just I really love the fact that there's just so many different things. You've got, the before and after from BQN. You've got stuff from BQN, stuff from Uiua, stuff from the OG, APL 360, and also Dialog APL. You've got the shape. And so there's just a lot to like, folks. And on top of that, you've got a completely different model from all APLs that exists if you exclude Uiua from APLs with the fixed arity, which leads to a completely different train model. But anyways, I'm going to stop talking. You now is your time. Introduce Fix APL to the world and wherever you want to start, and then we'll go from there, and we can ask questions and explore the language after that.
Okay, sure. Yeah, so Fix APL, absolutely, as was mentioned, influenced by a lot of languages, especially in the glyphs, but also things like the array model. It uses BQN's based model.
Mm-hmm.
So really a lot of things. But the language itself is, in essence, an APL with fixed arity functions, which means that instead of having each function, you can call it either monadically or dyadically. There's one way to call each function, right? And you can see it with the colors, like green shape. The shape of an array, you can only call it with one function, right? It's not overloaded to be reshaped with two, like it is in some APLs. We have a separate symbol for that, for the dyadic form. So in theory, this does mean there are twice as many symbols, but it actually ends up being less than that, because when you look at a lot of the monadic forms of dyadic functions, you don't really need all of them in a language. And it takes sort of a similar approach to Uiua in that way. But the reason for having fixed arity, there's really three of them. The first one is that just the overloading of glyphs can be confusing. Like when you have in APL, you have what's the classic from APL? I don't know, I'm blanking on it. But like in BQN,
trains or
no, but just like when you have like the ambivalence, the problem with one glyph having two meanings that are totally unrelated. Like I know in BQN there's windows and range on the
range, yeah.
same symbol.
Yeah, but
There's
it
some
seems
other
like match and depth in APL is really
right, yeah,
associated,
yeah.
right?
Or length and equals in BQN, yeah, or whatever that one is.
Yeah,
Range,
like not equals is length, which
yeah.
kind of is honestly, at least it's an educated guess, but it's just a similar glyph to tally in APL minus a
It's a
line,
simpler
right?
tally, yeah.
Yeah,
Same
so
thing
it's
goes with the equal and depth,
yeah,
right? So
Yes, it's clever in terms of the glyph, but if you're looking at it from a lens of it being like consistent in any way, it doesn't really make sense. So that's one. Another one is something I got from Uiua, which is that when you do have modifiers that can look at the arities of the functions that they're passed, you do get some interesting cases. And there are a lot of ones which I can get into later, maybe, but some of the biggest ones for APL are before and after, which I got from BQN, but they are modified and they just operate rather differently because they can switch rather than switching behavior based on the number of arguments that it's passed, it switches based on the number of arguments that each function is meant to take.
hmm
So you get,
all right, of
you know,
course.
several more cases.
So you get
And
a lot of compositions that are otherwise, like in tiny APL, you would need dedicated symbols for those compositions. So that gives you hooks, I would guess.
yeah, and I think there might be a few others.
But so how does
But
that
yeah,
work then? The function derived from an operator is ambivalent in principle, but determined by the operands according to some rule set, or there's a general rule for that?
um, it's different for every operator, basically, for every modifier. But like if I have, so like here's an example, one before add, this is gonna just bind one to add as the left argument. And what you can do is you can look at the arity of this by making it a subject and passing it to the arity function, and you can see it is monadic there. But if you have something like, I don't know, add before add, then you are going to get a dyad, and this is like writing. I'm not totally sure actually, but I think it would be alpha plus omega in parentheses plus omega. I believe so.
It could also have been the opposite, right? There's not really.
Yeah,
There's no
right.
way
If
for me
you
really to tell what it is. I guess you have to. It says you. Oh, I guess it makes sense if you say plus before plus, or I mean maybe take a different two different functions. Plus before minus. So then the idea is we have to evaluate
right,
plus before the minus, and since it's dyadic, it has to take both arguments. So there has to be alpha minus omega. In this case, yeah, if you want to do it like that, and then we do a plus, which has to be dyadic. So it has to take that argument on the left, and then something else on the right. Now, the thing it takes on the right could be anything. It could have been alpha,
yeah,
it could have been omega. There's not really any rule to say that, but it sort of makes sense that if it needs something on its right, it would be the right argument. I can see the reasoning. And
yeah.
and then if you wrote minus after plus, it would be the mirror image would be alpha plus alpha minus alpha plus omega, right?
Should be, yeah.
Something like that. You can't. Yeah, there's no. You don't
It's
have a
hard
way
to test
to.
stuff like that, but yeah.
No, it's not hard to test. You can just make this placeholder functions that spit out the results, the arguments.
Yes, right. We can do, and then 3. Yeah.
Well, okay.
So yeah, this is 3 plus 5 equals 8, and then 3 minus 8. I mean, these ones are kind of confusing, right? Because you're using two dyadic functions.
Yeah, it is.
I assume the ones where it's like
compositions are a little weird. Yeah.
Yeah, because like to have two dyadic functions with before or after means that basically one argument is getting duplicated within your, composition, and another one is just being used once. Whereas when you have like the hooks make a lot of sense, right? Like you've got two arguments, or well, I guess in the monadic hooks you have one argument, and then you're applying a unary function and then copying that argument and passing that to the binary operation. And then in the dyadic case, you're just applying the unary operation to only one of them. I'm assuming.
So here's a trick to make it really clear. I think at least really clear what's happening. I don't know if can I send it to you somehow? Yeah. I mean,
you can send it in the chat, and then I can just pull up the chat.
Yeah, I guess so. There you go. Or maybe Jacob should pull it up.
This might mess it up a little bit. There you go.
Take,
Everyone can see.
Copy that. And,
everyone except me, I guess.
Yeah, I can't see it either.
Here, how do I? We're playing with.
But Jacob, can you paste that into your session there?
Well,
or do you want me to dictate it?
I don't know. It's gonna be I don't know.
I can dictate it to you instead if you want. It's not that.
Yeah,
long.
that'd be better.
Okay, so then I can also explain what I'm doing here. This is a trick that I use in Dialog APL. It works very well here as well. So if you write quote x quote, open brace. I don't know what do you call that ligature? Okay, so alpha ligature, quote f quote, ligature omega, before, or close brace. You want to do close brace first, and before, and then write the same thing again, but with the same brace thing again, but with a G instead of F. You can just copy and paste it if you want. Yeah, and then a Y at the end in quotes.
Okay.
Yeah. Okay. So what's happening here is that the structure shows us what happened, right? If I'm not mistaken, right? So we can see that we got it's sort of a fork, right? The middle tine is the G, that's the top level function. We've got X, F, Y on the left and just a Y on the right. And if you go and recall this statement and then replace the before with an after, then we can see what happens when you use that other composition. And we can do this with every composition. Right? You can do this with over and so.
Yes.
And then you can replace the operands with monadic functions instead, and then we can see exactly what's going to happen.
Yeah. There's with monadic left and after.
So this is dyadic application of monadic F after dyadic G.
Yeah.
Okay, so that's on the top. Yeah.
Or
now this is really interesting. Yeah. What happens if you replace this with all the other
to make this monadic, then.
So this makes sense as well. This is a hook.
Dyadic hook.
Right, or beside if you want dyadically. And so on.
Do, all of them.
So what happens if you both sides are monadic but you still have a dyadic derived one?
Well then.
No, it didn't like that. Yeah. Okay. So that's an invalid combination.
You have X on the left, because
it couldn't figure out what. There's nothing sensible you could do with this. I agree.
Yeah.
But I think this is a pretty cool tool. You should almost add that, so I can translate my tacit so to understand what the combinations do. Because
maybe this is an interesting one because
Oh, go ahead.
This is an interesting case because you have the before with monadics on both sides, which means that you end up having G being applied after, which makes sense, but it just ends up being looking a little weird here because you have it getting past the function on the left as its right argument. So,
but that could actually be really useful because sometimes you want I don't know, but my guess is that your combinator bindings, or what do you call them, are like in APL, so they bind with a long left scope. And that sometimes you want on the top, but the right function in that top, the one you're applying first, is derived in itself, but the left one is not. And then you have to use parentheses But this actually allows you to swap the order.
Yes, it is very nice. It's a little bit like reverse the top in Dialogue 20, right? Or maybe I'm misremembering. I don't know.
No, you can't.
It's
We don't have
different.
that. Yeah, it's not.
Uh,
It doesn't do that.
okay,
But an
maybe I
example of that,
misremembered.
just as a silly example of it, is the negation of the sum, right? So I assume that sum is plus slash.
Oh yeah, so you would do
Yeah.
like
So you
before negation, yeah.
yeah. So you read this as sum before negation, which actually reads very nicely.
Yeah. So if you take the sum, that would be 1 plus 2 plus 3, which is 6, and then you negate it, so you get -6.
Of course, if you negate first, it will give the same result, but that's
Yes.
irrelevant for our our purposes here. But you couldn't otherwise write this. Right?
Yeah.
I don't know what that is. Contents.
Yeah, that is content. So that's sort of a weird thing that's not really specific to Fix Arity, I guess. It's just something I decided to have in Fix APL. But because it is sort of related to Fix Arity. In BQN, the reduce function it operates on the cells of the array that it's passed, which makes sense, but when you have a list, it makes sense for higher rank, but when you have a list, you have the cells of a list are rank 0 arrays instead of the atoms of the list, which is a little complicated, but it ends up being that if you just plus reduce a list, you end up with a rank 0 array containing your result. So you need to use content to get it as an actual number.
Isn't that why you've got fold?
Well, see, it's different because in Fix APL, fold is actually what Uiua calls fold. It's different. So fold in Uiua is for setting an initial argument as the beginning of the reduction. So it's a little confusing. That's why I want to write docs, but I haven't gotten to them yet. But
Who needs docs?
yeah,
We need more APLs. That's what we need. I'd rather have more APLs than docs.
Yeah, currently we've got documentation for fold as the docs, if that's what you're looking for. So
now we know.
Yeah. So that's, I guess, one thing to keep in mind. I might redesign it at some point, but it's a bit weird because if you want to have reduce as you want to have a version of reduce that does this content thing automatically for you, you need to have 2 versions of each of these reductions, or not necessarily all of them, but it just gets weird because, like, then do you want to have a content version of the dyadic reduce, or do you want a content version of scan? Actually, I don't think you need it for scan, but it's a bit weird.
All right, let's take a step back just so that we're putting the what do you call it? Audio only listener. We'll save them from the water, put them in a lifeboat. They might still be like drowned, but that's fine. So let's, because I totally haven't mapped all the definitions of the glyphs before and after that we were talking about. So if you got lost in that conversation, dear listener in Spotify or Apple Podcasts or wherever you're listening. We were talking about the glyphs that BQN I think initially had, which are very beautiful for before and after. And in BQN, because you have ambivalence, you end up with basically monadic and dyadic definitions of these, which map to the hook and back hook in both monadic and dyadic versions, which correspond to, like, I believe it's the S and the sigma and the D and the delta. So we saw that basically because we don't have ambivalence in Fix APL, you can think of having, you've got 2 glyphs, your before and after still, but you can have a monadic or dyadic function on both the left and right of each of these glyphs. And so, correct me if I'm wrong, I guess one of them didn't have a defined definition, but all the others, meaning, monadic.
Actually, all of them are defined.
All of them are defined.
Yeah, there was one where there was a residual thing that caused an error, but
Okay.
there was no,
Oh.
So can we rewind and just go walk through what, monadic before dyadic,
But
before
there's so
monadic?
many combinations, right?
I mean, we got to
There
know.
are.
The listener wants
for
to know.
every
There are a lot,
operator,
yeah.
And
there
even
are
if the-
there are two possibilities on the left times two possibilities on the right times two possibilities on the arity of the derived or the usage of the derived function.
I heard
Well,
2
no,
times 2
there's
times 2
only
is
Oh,
just
one
no,
eight.
it can't
use of the
be.
derived function.
Okay, so it's only four possibilities.
That's why there
for
was an
each.
error, because here, this monadic after monadic combination, I was calling it dyadically with X on the left, and that's why it was erroring, because it's only allowed to be called monadically.
Right.
That's
You got
just the
2
syntax
monads.
of the language.
But can you predict if I tell you that I've got in my hand a what do you call them? You call them combinators? What do you call them?
I guess.
Or modifiers.
Modifiers?
I've got a two modifier, right? If I got in hand my two modifier. I won't tell you which two modifier it is.
Mhm.
And now we're giving it a monadic left operand and a dyadic right operand. Can you predict
There's
the
no
arity?
generic rule.
Okay, so there is a little bit
It's
of
different for each modifier, yeah.
you can't. You have to look at the definition of the modifier in order to know the arity of the derived function. So you've sort of pushed off the problem of APL's ambivalence to derived functions. That you have to know the function itself to know the arity of the derived function.
I guess so. Well, you need to know the arity of each of the functions that are passed the modifier, and you have to know what the modifier's behavior is for those arities. So yeah, I guess so.
But I feel like this is unfair. If I understand the critique that Adam's making, I feel like it's unfair because all of this is perfectly knowable, right? Like you can't look at an ambivalent APL expression and know without context. But like as long as you know what before and after do, which
if you see the context, if I don't know the meaning of the symbols, but I know their syntactic class, which is a problem in APL, I'll give you that. In BQN, you do know the syntactic class of every symbol and every user-defined thing as well, because that's apparent either from the symbol's sort of look, or from the name of the thing you're calling, or from the content of the actual code that's between the braces. But if you know the arity of everything that you're looking at, but you don't know what they mean, meaning what they actually do, you still can completely parse what you've got in front of you. But here, you have to know the meaning of the symbol in order to parse.
That's true. Only for the modifiers, but yeah.
No, I got lost.
But you
want to take it again, Connor?
You have to know the. So we're talking about parsing now.
Yeah.
I was talking about
If you
readability.
give it,
well, we're talking about
if you give an
readability,
alias here, right? If you give an alias now, I don't know if you can do that, but can you give a name to a dyadic or a two modifier in
No, I
FIXAPL?
didn't add that.
Okay, but let's say we could. It means you can't define your own either, right? Because I don't see any symbol for operands.
No, there's no, yeah. I wanted to add
Yeah,
it at
there's
some
no.
point, but it's a little complicated to know the semantics of how it should work when you have fixed arity.
Yeah, but Connor, imagine here where it says after, right, in the input line.
Mm-hmm.
If we were hiding that symbol and instead we wrote mod 2 or something we had defined that was a 2 modifier that did something, you wouldn't know whether it was valid to give a left argument to this derived function or not. You simply can't know.
That's true.
And if you've got a black box 2 modifier here, meaning you can't inspect the code because whatever reason, however it's implemented, then you simply can't parse. Parsing stops here. There's no way for you to know whether it's valid to give a left argument or not to this derived function. In
But there
APL,
aren't
you have
any
to
black box ones, so
No, I understand. There can be, right. Currently, it's not a problem because there's a limited set of modifiers, and you cannot add more.
But yes, I see what you're saying. Yeah.
I'm still. I kind of get what the point Adam's trying to make. But so you're saying that you, because like, what is the underlying problem here? Is that because these modifiers, based on the arity that they're passed, can generate different arity functions, and end up in like ambiguity land where, but like,
Well, it's not ambiguous as such. It's just that they can choose by the definition what they do, right? They internally we could have a mental model of these combinators where as soon as you enter the code by them, there's a table or a case statement if you want, where it says, okay, what are the valences of my operands, and then it goes down and chooses what to do. And what it chooses to do is either strictly monetic or strictly dyadic. But that table is arbitrary. There's no way for you to predict it. You just have to know.
Yes. Although it's pretty simple for most of them. After and before are
don't get me wrong. I think this is beautiful. I think it's amazing. It allows all those sort of less usual constructions to be expressed very neatly with a small number of combinators. Don't get me wrong. It's just I just noticed that things aren't as fixed as you might think they are.
I'm still confused because now you're saying that the set of stuff that was chosen in this table that's being dispatched is arbitrary. I mean, isn't everything arbitrary? Why did we choose two trains?
No, we can come up with alternative definitions that are equally valid.
The point is that like if instead of before here I had 2 here, right, which is my dyadic modifier, then you can't know whether this resulting function is monadic or dyadic. Like it just stops here.
Yeah.
But
here's an example that will make Madeline really happy.
Language, but
right, not yet at least.
This is because you don't have the stuff that TinyApple and BQN have, where they have like.
No, it's not even that. I mean, sure, even if I did, it wouldn't change anything because this, like, if we assign this to foo. You don't know if foo is monadic or dyadic. Like, you don't know if you would call it with like this or with this.
It depends on mod 2, which might not be decided yet. So it's not statically parsable. It has to be. You have to know everything. But something that here's an example that makes this very clear. Something that will make Madeline really excited here. The over operator. Is the crossover thing when you make dyadic. So normally we do over, the right operand is monadic. It's a pre-processing function, right? Do this function f, but pre-process the arguments with y. But if you give it a dyadic function over dyadic function, then
it does what Madeline,
it does the swapped application of G, F, the normal application of G. You can type this up. If you go and take the previous statement we did with the whole pattern thing, to make it say what it does. Yeah, we could write like this as well. Yeah, okay, this makes it clear, right? But now we say that the swapped version is on the. Well, where's the swapped version on the right here? I thought it was on the left. Oh no, 2 is on the left. Okay, yeah. So you see the reversed version is on the left, and the normal version is on the right. But it might as well have been opposite, right? That's completely arbitrary. What it does with its operand. That's the definition of the over. Now the fact that it is dyadic, that sort of makes sense here, especially since over basically only makes sense like that. But it's still arbitrary how it chooses to pipe the arguments in. In the same way, with any way it uses the arguments, in principle, before and after, for example, could be defined as ignoring the left argument and only using the right argument the appropriate number of times for the operands. It makes no sense to define them like that, but you could.
I guess so.
And that also means that if you had dyadic function, sort of after dyadic function, it could have been a strictly monadic derived function that just uses the right argument over and over and over and over. It could have been. It doesn't make so much sense, but you sort of had to learn these patterns, and I find it really neat.
It's the same as the pattern of this. F after G self.
Yeah. Okay. No. Right. You could do that, and that makes more sense and is more readable and so on. But I'm just trying to communicate that it is sort of arbitrary how the plumbing is working out. Yeah. Whereas the BQN and APL operators are completely predictable in how they treat the argument. They're just patterns of application. And you can apply the result either monetically or dyadically. It might not work for those operands, but it does. But you can certainly do it.
Yes.
But now we need a in the documentation some auxiliary site. I don't know, FIXAPL card or something like that.
Yeah.
We need this grand table of all the compositions and what they derive exactly. That would be really neat.
That's a good idea. I should add that. I haven't. I mean, there's sort of a implementation detail, but the parsing isn't static. It is totally possible to do statically. I just kind of didn't implement it that way. So, in fact, like, it's impossible to write anything that you couldn't determine statically. But because of the way I implemented it, like, this actually. Well, actually, I don't know. It's sort of hard to explain. I'm not sure how relevant it is, but like there isn't actually a lookup table. Like it does. It literally returns a function that has this definition that does.
You can capture that. No, I think it does make sense. That it's not lazy in waiting for you to call it before it goes into the combinator code. Rather, it immediately returns a function that does that thing, that does that pattern. And I think it's neat. There's a huge potential for, we could say, overloading if you want, despite your best efforts, right? Because there are lots of arities of derived functions that are not defined, but certainly could be defined.
Yeah, or like with over the left function has to be dyadic, right? It'll error if you put a monadic function here. But in theory, I could define a new modifier here, where the left function has to be monadic, and there could be two new cases here. It wouldn't make sense for it to be called over, but I could. That's empty syntactic space.
Yeah. Well, it has to be a separate operator, right? Because how does it work? So is it the case that every operator, right? Every operator with a particular set of monadic dyadic operands has to return a static arity of derived function. Right. I think that's the rule. I don't know if I expressed that in a way that was understandable at all.
I've been lost since I said the last time I was lost. It's not Jacob's fault. It is Adam's fault. Although actually,
I'm sorry.
It's probably the ArrayCast disbanding's fault, because usually I used to just be the moderator and I get confused all the time. But now I'm half of a panel, of which I'm only like a blue belt or whatever is a couple levels below a black belt. Because if I'm confused, I guarantee you a couple listeners. Although, I mean, I'm looking at the YouTube chat. We've got Kai, we got Max, we got Madeline, we got implementers and creators. So potentially, I'm the only one that's confused right now. So here's my main thing where I'm hung up on is that I hear that there's some arbitrariness, but in my head I'm going aren't the semantics that are attached to everything arbitrary? I mean, not really, but we attach semantics to things, and I do understand that some of these glyphs can result in either a monadic or dyadic derived function. And I guess is the point here that in Uiua, Tiny Apple, BQN, you don't have that? This is a new thing, and that's what's confusing, because from my point of view, yes, there's overloading of the arity that can be passed to these modifiers. But to me, that is not confusing. That is a set of rules that you learn as a part of learning the language. And yes, if it's monadic before dyadic or dyadic before monadic, that's not confusing to me. You learn those rules the same way that you learn how to parse 2 trains and 3 trains. But the problem with you learn how to parse 2 trains and 3 trains in these array languages, and then you still can't know what the function does at the end of the day because you need extra context. Whereas here, you learn the overloading of the before and the after and the different modifiers, and like you know that table, and now with the knowledge of that table in your head, you look at the arity pattern, and then like you can just learn what it means. So that's what I'm hung up on. Is it sounds like there's some kind of thing where we're saying, oh, this is arbitrary, but like, is it just that the arbitrariness is the rules that we attached to the modifiers and that you have to learn them? Because like that is perfectly knowable, like knowledge that you can learn. Anyways, that's where I'm confused. Is like I feel like I'm missing a thing that like, yes, I understand you can end up with a dyadic or monadic derived function. I don't see a problem with that. Sure, for maybe that makes as a language implementer it harder to parse. Not my problem as a user. That's Jacob's problem. He figured out how to do that. Not my problem. And I guess it's also Adam's problem because he is head of language design for a dialect. So it's everybody's problem but the guy who's not designing the language, which is why I'm sitting here being like, this is fantastic for me. Anyways, please, and someone in the chat did say, I'm confused without the D. I appreciate that. So I'm not the only one. I appreciate it.
I think we can compare this a little bit to something that appears in J, and I think also in Sharp APL, old Sharp APL. So in dictionary of APL that Iverson wrote, he wrote about something called function rank, which for every function you define a monadic, dyadic, and ranks, and it's sort of like having the rank operator implicit. So, for example, the plus function is very simple. It's rank 0, 0. That means it applies. It conceptually applies loopingly to every subarray of rank 0. But other other functions apply to bigger ranks. So a very strict example would be the matrix inversion function. So matrix inversion only makes sense on matrices. In traditional APLs, including dialect APL today, if you try to apply it on something that's higher rank than 2, you just get an error. According to Iverson, the function of rank of matrix inversion is 2. It applies to matrices. If you apply it to an array of higher than 2, it's as if you wrote function inversion rank 2. So it just splits up the array into arrays of rank 2. Here too, in the documentation for the modifiers, you would write, for example, that this modifier has derived function valence, or come up with some fancy name for that, equivalent to alpha underbar. Is that right? Or omega underbar. Right. So say, so for example, we know that over has the valence of the left operand, and the left operand has to be dyadic. Right? So therefore, all derived functions from over are dyadic. But before also has the derived valence of the left operand, but it's unbounded. So you can set you can use any valence left operand, but then you can predict the right function will have that same valence as the left operand, and the right operand doesn't matter. The meaning matters with the right operand, but the valence doesn't. So did I get that right, Jacob?
I believe so. Yeah. Yeah. I'm not sure. Honestly, I'm starting to get confused. But
sorry, we're losing everyone.
Okay. Yeah.
I mean, Madeline in the chat said in APL you can't know what a function does if you don't know how it's called. And in Fix APL, you can't know how a function is parsed if you don't know the arities of the identifiers referred in it.
Yeah.
Oh, no, but you do know that the arity of the identifiers referred in, right?
Yeah. Yeah, you do. Because fine.
Yeah, that's what I'm thinking. Right. We know the arities of everything. That's either blue or green.
Is that like it would be more, I guess, perfect if you want, if you know, similarly to how in BQN and Tiny APL, the user-defined modifiers, you have to use these underscores. If there was an equivalent of that for functions, like if I had to write underscore foo underscore equals plus, or like if we defined this dyadic foo to if every dyadic function had to be written like this with the delimiters like that, then yeah, it would be, I guess, more parsable. It would be less ambiguous, but that sort of defeats the purpose.
Oh wait,
hold on, but are you saying that there's no I can tell on an APL symbol what arity it has by my internal dictionary of which ones do what, but I can't tell on a user-defined name what if it's monadic dyadic. I just realized now because I haven't played around with it. They all look the
Yeah.
same, right? That
Yeah,
means
like
it's
if I
not.
write foo is plus, right?
Yeah,
Oh, for some reason it's not highlighting. I don't know why.
that's right.
Okay, that was a weird glitch. I'll have to fix that. But it's highlighted in blue, which
Yeah,
tells you that it's dyadic. But if you didn't have any highlighting and you just saw foo, you don't know what its arity is, unless
I see.
some language where it was written like this.
Right, exactly. And now if you use foo in a derived function, you really don't know what's going on. If you write foo
Yeah.
over bar, you have no idea whether the derived function is monadic or dyadic because it depends on the arity of foo. So you can't statically parse this as far as
So
I
yeah,
can tell.
once again,
You have to know
this
the
seems like
definition
an
of foo.
implementer versus user thing. Because like I'm thinking, like we only have fixed arity functions. So like,
Yeah.
don't
You
we
have
have
syntax highlighting.
we have
like,
fixed arity all over the place? Even if I can't tell. Well, I guess that gets back to the readability thing. But like, assumably, yeah, like whatever you do a subscript 1-2 or the underscore before and after. If you make it some way, like we do, it's not like you're going to end up in a situation where the function can either be monadic or dyadic, and therefore we now are back in like APL land. It's always going to just have either. Oh, except.
Well, let me ask another couple of questions. Do you have? I haven't tried this, but do you have like defin guards where you can return something based on the return now based on the condition?
no.
Okay, so the
I
control
would.
structure.
There's no reason not to have them. I just didn't add them.
Well, there is because if your functions can return functions, and you can have guards, then a function can
well,
return.
but a function that returns a function, it returns the function in subject position, and then so that's maybe a good thing to mention is
Oh, yeah.
like, say I have this list which contains plus. If I get the first element of plus, it's this, but I can't. It is plus the first
But
element
it's
of the
still
list, but
an
I can't write
array
it like
sort of
this.
thing. I see.
Yeah,
So you
because
have to
and then if
activate
I
it.
want to call it, I have to use this dyad, this modifier dyad, which lets me
I
call it.
see. What happens if you call it with a monad modifier?
Then I don't remember if it errors or if there's coercion. Yeah, I guess it errors.
I see.
Wait, so walk us through what we just introduced here. You've got subscript 0, 1, and 2, which is for, I'm assuming, nilad, monad, and dyad, and these are modifiers?
Yeah, so there are these monadic modifiers, subject, monad, and dyad. And the idea is you can use them to move functions from the subject position to the function position, basically, which is sort of a weird thing to explain. But if you have 1 plus 2, this is going to work because the plus is in the position of a dyadic function, and it just knows that. But if I have a list that contains plus, and I get the first element of that, it's still the function plus, but it doesn't have the right syntax position to be called like this.
It's become valueified, right? It's
Yeah,
now
it
the
becomes
value plus,
value.
not the function plus. But then I have a question then.
Yeah.
According to the coloring and the claim of the pop-up, the subscript 0
Yeah.
is a monadic modifier, but that does
Yes.
not seem right. It seems to be special syntax, right?
Nope, they're
Because
all modifiers, but it's just, well, it's hard to explain basically. I
it
guess you
derives a
could see
nilad, I
them as
guess.
special syntax, but internally they are just modifiers. But yeah, maybe they should be colored differently. I don't know.
Because well, maybe
They're
there's
parsed
a
the
thing
same
that
as monadic modifiers, but they work a little they work differently from the other ones. Yeah.
because normally, well, maybe it's just the way I think about it. Normally, when I apply a modifier operator to a function, then the derived thing will always be a function on its own, or in some APLs you can derive a monetic operator from a dyadic operator, but it doesn't matter so much. But here, could it be that we have a modifier that derives a nilad? I mean, derives a value instead.
Yeah,
And I think J also has something like this, but I'm
you can
always
do
been
that.
confused. Yeah,
Like,
but
for
I've always
example,
been confused on how does that work? Because how does it know when to apply it? But maybe it's not a problem. Maybe it's just me. I don't understand.
yeah, it is. It does parse, right? Like if I have one each, I think that would work. Oh no, it errors. Alpha must be a function. So
Yeah,
I don't know.
but you can
I
do
believe
you can
some
put
of
a
them.
1, right?
What do you, oh, one sub one, you like this?
Yeah, 1 sub 1. So this makes 1 into
Well,
a
I think
constant function that takes
it
1
would, but
argument,
I
and then
think yeah, I guess so. Then you could do that, yeah. But other the normal way you would write, yeah, maybe that should error, I guess, because the normal way to write a constant function is to use self.
there's no difference, right?
Yeah, they are the same, but maybe maybe that should error, but it doesn't.
But then you need self for something that takes 1 argument, and you need commute or whatever backwards
Yeah,
for
back.
something that's 2 argument.
That's why
But it's
there's two of them. Yeah.
it's almost clearer to write it with a subscript. You just write 1 and
Yeah,
2,
maybe
so
it
you can
is.
see this is a constant 1 that's monetic, a constant 1 that's dyadic.
So I guess maybe it's better to just write it like this. I'm not sure.
Wait, explain the. I was following along that because I ran into that myself. You have to split the self and swap, or the C combinator and the W combinator, into 2 different glyphs. But what are you doing with the subscript 2 here? The dyad turns this into what?
So
Yeah.
1 is
So
a constant, right? It's
Yeah.
a value,
yeah,
and we want
one
to
is a
make
value.
a constant function from it. So the
Mhm.
constant function also has to have fixed arity. So is it a monetic constant function or is it dyadic constant function? So there are 2 ways to
Yeah,
do it. Right?
yeah. As Adam's saying, there's 2 ways to do it. You can either make a constant function monadic or dyadic using these sub 1 and sub 2 glyphs, or
Mhm.
you can use self or backward. And like you can see here, it's called
Oh yeah,
self slash
const 1 and const
constant
2.
1 and const 2. But I don't know, because you can also do it with the subscript 1 and subscript 2. So I'm not sure which way I like more. But both ways are equivalent at the moment.
Well,
That's
there's
all
so
right.
much to
I love
say
Tiny
in
Apple,
this.
and there's like 700 ways to do everything there. So
Yeah. I mean, I'm
Yes.
fascinated by the design space that is in this language. It's sort of a small language
Yes.
in the vocabulary, but in a way it reminds me of K. I guess this is similar to K, because in K it also looks sort of at the what types you're giving things, and then things have different meaning. So I just realized that because of the strict way that the operators work here, then there are actually 3 options for every operand. You could also give a value as operand, like I suppose the rank operator
Yes.
takes the value, right?
Most of them don't accept it, but yeah.
But that doesn't, yeah. And for example, there's no so I don't know if transpose is monadic or dyadic. I can't tell because of the colors.
Transpose is monadic.
It says there on the pop-up, yeah.
Yeah.
But for example, if I do reverse, no, that's rotate. Sorry, reverse. If I do like a reverse reduction, it doesn't currently have meaning, but you could define a meaning to a monadic function applied with reduction.
Yeah, I could.
And if I understand right, this is exactly what K does. So if you give a dyadic function with reduction in K, that's reduced, fold, whatever you want to call it. And if you give a monadic function, then it's fixed point. Like it applies that function over and over
Oh,
again
does it?
until, yeah. And it
That's
has a
very
whole
interesting.
system with a forward slash and backslash. But they're all related depending on you give it monadic functions or dyadic functions. They all do the thing. So scan with a monadic function is also fixed point, but it gives you all the intermediary values.
That's funny. Yeah. So I guess it is like K in that way.
Yeah.
Which is funny. K is the language that is famous for having all the overloading. Fix APL is supposed to have none, but in a way, it's the most similar.
Well, so too, Fix APL has heavy overloading.
Of course, it does have heavy
modifiers.
overloading with the modifiers, yeah.
Yeah.
But it's just conceptually, yeah.
Yeah. The before and after carry a lot here, whereas in APL BQN they don't need nearly as much.
Yeah. Okay. Not sure what we should talk about next here.
Well, I mean, I've got a bunch of questions. I was just thinking in my head because I'm still trying to clear up the confusion. But we'll circle back and we'll just don't worry. I'll spend some time playing around with this. We'll have it back, and then we'll be.
I'd like to talk about trains at some point, but.
Oh yeah, that's the thing. Yeah, like so. We'll do that now, and I'll save my questions. Or at one point, we'll go through all the glyphs. We'll rapid fire. But yes, I mean, we also have a different train model, and that's the thing. We haven't even gotten to trains yet, which is ridiculous. That we were, or not ridiculous. I guess it just shows you the power of the modifiers in Fix APL.
But kind of maybe a thorough treatment of Fix APL's tacit programming is an episode on Tacit Talk. I won't say it.
Maybe.
Oh yeah.
Just leave that there.
We got two podcasts. We can have you on them both. But yes, let's move to. So for the audio listener that got confused and is still listening for some reason, thank you. We appreciate your valuable time. We were up until this point talking about Glyphland. You know, we were talking about the before, the after. At one point, we were talking about over, talking about rank, talking about the sub 012. We haven't even talked about trains, folks. These are different trains than you're used to because we now have fixed arity. All right, over to you, Jacob.
Yeah. So the basic idea of trains is similar, but it's not quite the same. I'd say the first major difference is that you can have a train whose rightmost time is a value, right? Which is very different from APL. In APL, if you write +1, it's just going to give you 1. But in Fix APL, it gives you a monadic function. And if you write +1 in parentheses, it's 2.
Sort of a projection, right? Because you filled one slot of the plus, so there's one slot left. That's again like K does it.
Yeah.
And the same thing goes the other way. You can write 1 plus as well because it's a dyad on the right, so it has to have something more, so it knows it's a train. That's very neat.
Yes. So that's maybe the first difference. Another major one is that because you know what's monadic and what's dyadic, you don't have every application be a fork. You also have a top, and it's very implicit. So maybe a simple example would be the length plus the, I don't know, maybe the square root plus the ceiling, say, of the, or maybe actually, you know, it would be easier. It would be easier to just do something that you can see with couple. So we can have, or pair, the
you just do round up and round down.
Maybe.
Yeah, you could do that as well. Yeah, that works.
The sign and absolute value of -4 gives you a fork, right? Where you have the two monadic functions being applied to the input, and then they are passed dyadically to the middle function, which is couple. So you get -1 and 4. And this is a classic fork. And you also have dyadic versions. So you have maybe sign and then equal. So we can put 3 here. And here you have the sign of -4, which is -1, coupled with the 3 is equal to -4, which is 0.
Wait, hold on, what? Why did it decide to take the sign of the right argument, not the sign of the left argument?
Yeah,
I understand that sign is monetic, but how did
it takes the sign of the right argument, and that's it's arbitrary basically, but that's the way I decided to do it, and perhaps it's not the most intuitive way, but I thought it was more consistent with the monadic version, because if this is monadic, the monadic function always applies to the right argument. So it seems a little weird for just because you switch one function to be dyadic, the monadic to the left argument instead of the right.
I mean, yeah, I guess so. It makes sense with like the main argument is the right argument, and like
especially
the left
if you
argument
switch
is
it around, like if you write equal coupled with sign, you can see it may be better.
Yeah.
The sign in both situations is treated the same.
Yeah.
So that's the first thing, I guess, is your normal, basically your normal forks, just a little different. But then you also have a top, and it's quite normal. So you have, we can say, the square root, or maybe
square root of the absolute value.
is a
That
good one.
works.
Square root of the absolute value, sure. And that works how you would expect. It does the square root of the absolute value of the input, so with -4, you get absolute value is 4, squared is 2. And you can combine this with forks. And this is not specifically because it has 2 tines in this train. This is just the way that it is parsed. And it can be with any number, not just 2.
Now you can negate that, for example.
Yeah, the negation of that. And in another language, this would be parsed as a fork because it would treat square root as some dyadic function, which doesn't exist. So I guess it would error. But here, because it knows that square root is a monadic function, it treats it as a top. And you can mix this with all sorts of different trains. But like if we have the function, if we add -4 to this -2, you can see we're combining a fork and a top.
How do we? The grouping is not clear to me. Like, how do I know? Does it group from the right or?
It groups from the right.
Yeah, because it's sort of greedy. It takes all the monadic functions on the right. We could also understand this as ID plus negate applied to the result of the square root of the absolute value. I mean,
well, this is not dissimilar from.
You could even parse it like this, where
I understand.
ID plus is treated as its own function.
So
I think that's more similar to how it is actually parsed.
But for a train, we start on the right. We take as many monadic functions as we can find, and they get coupled together, right? Or you could
sort
say
of,
do it
but not exactly, because you can also switch it around and have it on the left, and you can have any combination.
How does that? Hold on. Okay, try this. But now you can't have ID here, right? If you put ID on the right,
squared of, maybe we can have.
Did they do the same thing, but put the ID on the right of the plus?
Yeah, you can do this.
Hold on. No, that's
gonna be a bad thing, but
yeah, okay. But that doesn't matter so much. But if you remove the left ID here,
yeah, then you're getting something else where you have the absolute value plus identity.
Yeah, and then we apply the negation of.
Oh, actually, you do need identity. Yeah.
Yeah, but this makes sense. It always gives 0 for every number, but
yeah, this is a bad function.
But for every real number, it gives but it doesn't matter so much.
All right, so let's pause here because we lost the audio listener because we're not explaining. We're building up trains here.
It's very hard. I feel like it's hard to explain trains to the audio listener now.
Oh, no, it's pretty easy. It's pretty easy because we got green function, we got blue functions, folks. That's all we got. Right. It's real easy. We got
but hold on. The audio listener might be listening and not looking because they can't see. In which case, using the names blue and green is not going to help them.
Oh, it doesn't matter. It's just the pattern, right? So right now we are building. We started off by looking at the forks, and there's a couple different overloads because now you can have like. The way that I think of forks and APL and friends is you've got the monadic, which is 1, 2, 1, and you've got the dyadic, which is 2, 2, 2. Those are the arities of the function, and because
those are the only patterns.
Those are the only patterns, and we showed earlier some 2, 2, 1, some 1, 2, 2s because you've got fixed arity. It enables you to do this like arity pattern matching, which is what I was going to say earlier. This is not dissimilar at all. In fact, it might be very similar to what Jelly does. Basically, it looks at a sequence of arities. I talk about this in an unpublished paper called Trains, Chains, and Function Composition or something, that this idea in jelly of chains, where you basically just look at the arity of every function, which is why the listeners probably being like, blue functions and green functions, what the hell is this guy talking about? A green function is monadic, a blue function is dyadic, and that is borrowed.
I just wanted to jump in here and say this is so classic, Connor here.
What?
So you speak about it in an unpublished paper. That's like as tacit as it can be, right?
I tried to publish it. The wonderful folks at Array, the PLDI co-located workshop said that it was not novel enough or something like that. I don't know. I didn't have it peer reviewed. My other paper that was published was peer reviewed, and this one I kind of wrote at the last minute.
Okay, so we've got a train that read from left to right is monad, 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 dyad, monad.
But it's better to read it from right to left, seeing as we're parsing it and grouping it from right to left. So it's and also too, monad, dyad. Let's just do 1, 2. So it's 1, 2, 1 is your fork, and then we had 1, 1. And so then you're just applying those monadic operations afterwards. And before we had 1, 1, 1, 2, 1, which means you're kind of combining those unary functions with, that's the classic unary function composition. And then at the tail end of that, that kind of formed unary function with the 3 monadic functions, now all are treated kind of as the single function to a monadic fork.
You lost me, and I'm even looking at it.
I mean, the point being here,
He's talking about this one.
Yeah, that's where we started.
Yeah, this is what we started. So the simple case, easy to understand, is 1, 2, 1, 1, 1. Right. So there we start from the right. So we've got the 1, 1, 1 sequence that all just groups together, applies to the argument. We have to say also this train is applied monadically.
Wait. Are you talking about? You said start from the right, but then you said
This one,
1, 2, 1, 1, 1, which is starting from the left.
Yeah, I'm reading it from the left. I'm applying it from the right. Come on, this is hopeless.
I mean, it's not hopeless, but we got to agree which way we're reading it.
I saw some list of programming languages that was like comparing them to cars. And APL is a bus. It takes all the values from A to B at the same time. The only problem is that the signage is in Greek and the bus is driving backwards.
Oh, yes.
Greek. It should be like hieroglyphics if we're being, fair. Anyway, so when Adam said 1, 2, 1, 1, 1, he was reading that from left to right, but we parse it from right to left like the rest of APLs.
Yes.
And then we went on to say that if you switch the order of that, so you put the 3 monadic functions at the end,
on the
aka
right,
the left.
At the end, Mrs. Left. Yeah, thank you.
Or at the it's impossible. You then start with. I mean, this is I guess why we've never shared screens on the podcast before, folks, because it just evolves into colliding with the audio listener. You then start off with the monadic fork, the 1, 2, 1, and then that's followed by 2 more monadic functions. So it's very interesting because you like this is why I find like Cap and Tiny Apple and now Fix APL, like these are all such interesting models because you can achieve different things with different tacit models. Like Cap did away with the 3 train, made the syntax explicit, and then gets the composed unary functions just for free. And then the initial thing that you had, which was kind of like the juxtaposition of a nilad and a unary or a binary function, that's like falls into this arity pattern matching. But Cap gets that via left-bound functions, where if you have a binary function with just a left argument, it just automatically parses that as like a partial application. Whereas here,
it's like a form of fork, kind of.
Yeah, it's like you're treating this as if you read the arities of this like you would in jelly, it's a dyadic, and then on the right argument is a nilad. So it's like 2, 0, and if you reverse that, then it's 0, 2. And so you just I don't know how this is implemented. We should. I guess you did mention that Fix APL implemented in TypeScript.
Yes.
But I assume that's what you do. You look at the arities and then you dispatch based on that. Or is that correct, or is it slightly different?
Yes. It's kind of complicated, but yeah, it does look at all the arities and then read it from right to left. And yeah, it breaks it into, it treats the rightmost thing a little differently from the rest, but it reads kind of the rightmost section. Then after that it either reads a monadic function or a dyadic function and then another one.
Yeah,
So you
that's
end up
the thing. The scope is
breaking
short
the
on the left.
expression into, yeah.
It's interesting also because the way that traditional APL trains and J trains work, it's actually that dyadic functions are taking on the role of dyadic operators. There's a little bit about the binding. It's from left to right, right to left, but that's sort of just a rule we apply. But the original idea about the fork came from wanting to have an operator, a two modifier, that acted as a function on the results of its operand. So if we take like a very simple example is plus comma or plus catenate minus, right? So there you could think of it as, oh, what if there was a catenate operator that took two operands, and
Yeah.
the effect of the operator was applying the left operand and applying the right operand and catenating the results together. So too, for every dyadic function, there exists an operator that does exactly that. And Iverson was all in like, uh-oh, we have to add as many operators now as there are functions, or
Oh
dyadic
my
functions
god.
at least, right? So, and he actually came up with a scheme, a spelling scheme, where you could take the symbol for a dyadic function and overstrike it with an overbar, and that would make the corresponding dyadic operator.
Oh wow.
So plus overbar and times overbar and divide overbar and so on, so on, so on. But then they realized, no, we don't need to do that, because by syntactically isolating them, so that's the cost, right? You're putting parentheses around them and naming them. Then it's clear, since it's a syntax error in old APL, it's clear that the middle function acts in this operator role. That's where trains came from. That's where forks came from.
Interesting.
And here we sort of abandon that idea, right?
Yeah. It's not really treated like that at all. Yeah. It really just breaks the whole expression into kind of two patterns and just reads them all, rather than, and it's totally consistent with both expressions that are nihilatic and expressions that are monadic or dyadic or whatever. They all follow the same rules. Like there's no difference between writing 1 plus 1, which is 2, and identity plus 1, which is a monadic function.
Right. Fascinating.
So I guess, I mean, I ran into this when I was trying to put a hook, I believe, at the beginning of a fork, but it wouldn't parse the way I wanted. And then I got Claude to go scrape all the docs, which didn't exist. And then it said, don't worry, we got the implementation. It's open source. So then Claude went and figured out how everything worked and then came back with the correct answer. It said that if you want the hook at the beginning, it will aggressively read it as a 1-2-1. So that'll treat it as a fork. So you need to parenthesize. I can't remember if it was a 2-1 or a 1-2, but in that instance you had to parenthesize the 2-1. But now, after having had the before and after discussion, is it actually the case that if you've got a hook that precedes a fork, so you want to do a hook first, then a fork, you could actually use before or after instead of the two parens?
You still have to parenthesize. You still have to parenthesize. Because of the scoping, right? The long scope. So trains group from the right. And if you want a hook, say, where you want essentially you want a function applied on the argument as both its arguments, but you want to preprocess on the right, that preprocessing, if it's part of your train, has to be parenthesized, or the operator that's way out to the left will grab only one time. Does that make any sense, Connor? Because the operator binding is much stronger than the train binding, or rather, there's no train binding, right? They just sort of sit there.
Yeah. Right. Like
So
you
no,
can even
you
see
can't
the bug
do that.
just kind of there.
Uh,
It's like a
it's little
list.
bit-
Maybe I'm gonna have
yeah.
an existential crisis soon because on my most recent ADSP in the cinematic, code report podcast universe, the most recent ADSP podcast was I went on a rant about PEDMAS and how that's like an arbitrary hierarchy of evaluation that is just ridiculous and array languages are better. And then
But we have it too.
I know, and then someone had a very thoughtful response in the GitHub discussion saying, I find it very ironic that all these array language people, they bring up how their linear evaluation is so much better than PEDMAS, and they never acknowledge the fact that there is a ton of precedence. And then he linked, or she, I actually don't know, or they linked to the APL wiki precedence page. And then I was kind of, well, first of all, I was very thankful. It was a very thought-provocative post that led me to hours the next day thinking about this. But then also it was worse because I had never read the precedence page. And at first I was kind of like, well, stranding is kind of fixed, BQN, Tiny Apple, we've all fixed that. It's only exists in APL and J. But then when I kept reading, and it was talking about what Adam just mentioned, the long left scope and right scope of functions versus operators. And then I was like, yeah, I guess there are times when I'm using, I want to sum over something and I have to parenthesize the sum in order to get the correct binding of the modifier or the operator. But then while I was writing it, I was like, wait a second. All of this train stuff that I have a whole podcast called Tacit Talk. I love all this stuff. But it technically is not necessarily like the order of evaluation, but it is a bunch of context that the way that you read this stuff. And, half the time I get confused if I'm in a language that I don't spend enough time in. And anyways.
I mean, yes, there is a precedence, absolutely, and binding strength, whatever you call it. Maybe not in Uiua, I'm not sure, because it's really just a fourth.
Not really. I mean, there are, in Uiua there are modifiers, but that's the only precedence rule, really.
Yeah,
and I guess
but I think a big difference, Connor, is that if you think about growing the language, if that says anything to you, the precedence rules in, should we say, popular languages, languages that share syntax with C or are closely aligned with C, the rules get worse and worse. The bigger the vocabulary becomes. Whereas in the array languages, the rules only get worse the bigger the number of syntactic constructs become. But generally, a language will have or should have a large vocabulary, but a low number of syntactic rules or syntactic constructs. Right? So once you master, stranding and dyadic operators and monetic operators and all those things, right? Those rules apply universally. But look at this list of JavaScript precedents.
Yeah, this is JavaScript precedents,
so
and there's 15 levels. Oh, there's even more.
There's there's sub-levels. There's sub-levels inside the levels. It's a two-dimensional level system. And not only that, the system is so bad that there are things you're not allowed to even put next to each other without parenthesizing because it's just too terrible, right? So there are things, even though it has a rule here, a parent rule here, if you actually try to put some of them next to each other, then the JavaScript interpreter will blow up at you and say, oh, no, you're not allowed to leave this up to the table. Rather, you must force order.
Yes,
that's how bad it is, right? And it's like with some of the newer ones, like the nullish coalescing things, I think are like that. So I would say
this.
Yeah, own it, right? Yeah, those are not allowed to just arbitrarily put next to each other. Let's own it. There is a table of rules for how things are applied, even in array languages, like only in array languages. Only we have it way better than they have it anyway.
It's a lot smaller.
Yeah, I guess that's
you can't.
I've been trying to figure out a way to articulate it, and maybe you just have. It's that, like in C++, there's a similar table for this that honestly, like most people aren't even aware of, and that's because the best practice is not to rely on the precedence
No,
thing.
that's-
It's just
which
like
means something is broken,
just
right?
use like parentheses because, like, sure, maybe you have the table memorized, but if you don't, like, if you're working with someone that doesn't have, expecting that they will have it memorized, it is not a good like best practice thing. And I think Jacob's.
Hear me?
We can still hear you.
Yeah.
Can you hear us?
My headphones died.
That's all right.
But
There doesn't seem to be any feedback, so.
No, it's good.
okay.
Yeah, so the rules are very set in the array languages, right? And if you expand the vocabulary, you add another thing, right? Let's say somebody decides in JavaScript, well, we've got to add a new thing, right? You know, the equality, it doesn't work on properly on say arrays. We've got to add equal sign, equal sign, equal sign, equal sign, and call it equality for good, right? And now you have to add another level in the table, or a new sub-level in the table. But if somebody adds another primitive to Fix APL or Dialog APL or BQN or so on, there's nothing to be done. You just you say from the outset, what am I adding here? Is it a monadic function, dyadic function? Is it an operator, monadic, dyadic? Right? It's very rare to have a new construct. It can happen, like Dialog version 20 added the array notation, but the array notation's nature is such that it does not come into any. There's no question about what the binding strength is going to be there. So
Yeah.
nothing changes on
You
the
got
procedures.
separators.
Yeah. And the same thing here, right? There's a little bit of a question here. If we look at Fix APL as in like, okay, take any other APL and basically just modify the vocabulary, because many of these languages are just that, right? And then there's a little bit of question about those subscripts, about what exactly is the nature of those. Those are not, they don't conform to the normal rules. And you can see it as well. Dialog APL has a couple of things that are sort of don't conform to normal rules. You have to learn ad hoc. Like we mentioned, the outer product. There's actually a fun thing is the quad off and system name, which is a constant. But you can still give it an argument, sort of. It reacts to being stranded with another element. And so those are like syntactic quirks that are there, but they're very far and few in between. And we notice them so much in APL land because the rest of the language is so uniform. Whereas many other languages is such a mess that you don't like one more quirk. Yeah, whatever.
Yeah, I guess that's makes me feel better about my. Maybe I won't have an existential crisis. We're better. Yes, we have precedent.
Crisis averted. We'll tell your wife. No, not to worry.
Yeah, well, I already told her. So it's not about the existential crisis. I told her about the precedents. She didn't really care. I mean, she thought it was kind of interesting, but I think, to be honest, she was just humoring me because I was all worked up about it. And she's happy to listen to me be worked up about something, even if she not necessarily a super fan of the topic. Is there more to say about the trains? Because we got a little bit distracted and went on an important tangent. But yeah, is there more to say about the train model in Fix APL before we move on to the next question? Because we're already past the hour-and-a-half mark. But I got one last question I definitely want to ask.
I also have a question about the trains here. So you mentioned, Connor, the what did you call it? The application of a dyadic function with a constant on its left that you get in cap for free, and K also has that
function. Yeah,
left bound function. So here we saw that already. Like you can write in parentheses 1+, and that's fine. But if you want something like that inside your function, so then how exactly does it work? So
so like 1
constant,
plus, I don't know,
1 plus the average, right? If you write plus slash divided by the tally or whatever you call it, length. Yeah. So what just happened here? Never mind that contents thing.
So this is parsed as the length, and then so this is kind of the first thing is we get the length, and then here we have the sum divided. That's kind of its own thing, and then finally we have 1 plus.
But the 1 plus is not standalone here, right? It's, or is it? I'm sort of unsure what's happening here.
Well, kind of. It's not parsed, but it's the same as this basically. It's treated exactly the same as this. This is
So you go. Oh, that's what you said. You
identity
go
plus.
towards the left, and you see a dyad, which is plus here. And so we go one more step left and find something that we can use as left argument, whether it is a constant or a function. If it's a function, we need to apply it. If it's a constant, we just use it as is. So essentially, just like dialogues, AGH trains, we call them, where the array can take the position of either monadic or static function, depending on the valence of the train usage. So to here, the plus is effectively working as a function that a constant function.
Yeah. Effectively.
So I'm surprised actually. So the 1, 2, effectively 1 from the 1 contents reduce, that forms a unary function. That doesn't form the equivalent of a monadic fork, and then is applied first. It applies tally, and
No,
then moves
but
on.
that's interesting. So
well, it's
plus reduce divide does not form a tine in the overall train.
yeah. This is not its own function. This is just the order that it's parsed in, kind of.
Yeah, the same thing happens in normal APL. But if you put a space here on the left of the divide, I think Connor will recognize it faster. What's actually, I mean, the same thing goes in normal. When you write normal APL or J or BQN average, right? Plus / divide by tally. I mean, you use that plus / sort of groups together with the division. That's a train rule that trains each intermediary carriage in the train has a short left scope, hatching its left argument with a function or array that's on its immediate left.
Oh, interesting.
So we can treat them together, and that is a nice way to sort of read them and explain it to people. You write 1 plus the sum divided by the tally.
Yeah,
but there is no
that's
binding.
the idea of
going on
spacing
here.
it like this.
Yeah, there's no binding.
No.
Or if you would say the binding here is of all 3 rightmost carriages, the sum, the division, and the length.
Yeah, you could say that. Although
it will parenthesize it like that, right? If you remove the argument now and press enter, I think it will
no,
show
it just
you.
kind of spaces
It
it out
say
like
anything.
this.
Oh, that's interesting.
It used to
can't
have
really tell.
parentheses, I think. I'm not sure. Well,
It
no.
doesn't. In some cases, I've seen it in adds parentheses, and so
Yeah,
here's
in general,
an
with the
example.
trains, it doesn't, but maybe it should.
Yeah.
How have you found this? I mean, so you've done some J programming, you've done some Uiua programming. How do you find this tacit model compared to your other? And you also did some Tiny Apple.
I quite like it. I think it's basically, if you want to use it like how you write trains in APL, it's basically the same. It just lets you have more options, kind of. And it means that there are more things that you can write shorter and more patterns that you can express tacitly, or at least without lots of parentheses or combinators. But you still have the combinators before and after and all of them if you need them, and you can combine them with trains, which I think basically means whatever you want. You very rarely are going to need to add extra parentheses to a train.
That sounds like a dream to me. We all know that parentheses are the worst.
You also need less right text, left text.
Yes, fewer. The left text and right text are only for dyadic functions. You still have identity, which you have to use sometimes. This is just the monadic identity function, but it doesn't come up that often. And like, for example, with this, actually, I'm trying to remember. Yeah, with this, you do need identity to the right to have it like this, because otherwise, if you have the dyadic function as the leftmost tine, it wants to read it as a fork, so you would have it like that.
but you could also express this if you go back to the previous one where you're adding the identity to the average.
Yeah.
One up there, that one. You can, instead of doing this, we can write that as a hook, right? So you can remove the identity,
Yes.
and then you write on the right of the plus, you write after, and then you have to add parentheses there.
Yeah, like this.
Yeah.
Although you actually need to put self because of the way it is. But yeah.
Oh, all right. There's no monetic hook.
But you
Right.
can write it as before plus,
Yeah.
and that will do what you want.
Yeah, that's actually
And
eerily similar to what dialog has with beside and before. They one of them also needs the self, and the other one doesn't.
yeah.
Wait, so why is there no monetic hook?
There is, but only one, not two.
So
Right,
that's
there's
things,
two
yeah,
hooks.
like BQN
Like
has...
one, this is the hook. That's like that. But if you have like this is a monadic hook, but this is dyadic. If you it depends on if the dyadic hooking function basically is on the left, because if it's on the left, then it wants to read this as the left argument, whereas if it's on the right, then actually, wait, what?
No, one of them becomes a projection. They're not hooks, both of them. Right?
Whatever you want to call it. Actually, this one I'm
That's
not sure
cute.
why it does that. Maybe
This-
it's actually, I think I know why. I think this is a weird case. I think it might be parsed as a top, but I'm not sure. The hooks are weird. Basically, I try to avoid using hooks because they're a little unpredictable because there's so many ways they could be, and I always forget which one it is. So I might change them in the future.
But you don't need them so much because of the cleverness.
You don't need them that much, yeah.
Of before and after. Those are explicit hooks. Right?
Yes.
When you use them correctly. So using a tacit hook here is not really that valuable.
But
yeah.
But there was only one monadic. So like I think of there's S and sigma, like a monadic hook and monadic back hook, but you've only got one of those via the before and after, or you have both of them?
Well, you have both if you use self. I think if that's what you mean. Like, if you write,
but that's the same thing in APL, in dialog APL. You also only have one, but you have both if you use self.
I see.
If you write plus after average, what it wants to do is this could be monadic, but it could also be having the left argument be passed to this plus. So it just does that because that's the more general version. And if you do want the more specific, it's just one character, you add self. So I thought it was more useful.
So if you come full circle to those lookup tables, basically we've got the after operator here, and it says dyad after monad is a dyad. Strictly a dyad. You cannot apply it monadically. Therefore, you have to use the self to change the dyad into a monad.
Yeah.
But this is exactly equivalent to how you have it in dialog APL right now. It just happens to be it falls out like that, right? If you write plus beside average, right, then it will apply it's not exactly the same. It's very similar. It will not try to apply the plus statically and make a projection like this, but it will just apply the plus monadically because there's no left argument. If you gave it a left argument, it would be the same. If you put the self, then it does what you expect it to do. But if you do average before and plus, then it does what you want.
So basically, you're saying that in APL, in dialog, you have both this and this are allowed.
Yeah,
right?
because the ambivalence, right? So they do, both of them are applied immediately. One is just on the top, but the effect is that we've got three different top operators in dialog.
Yeah,
because of the ambivalence, and they'll have we could have defined them as having different meanings, but we didn't because it makes the most intuitive sense that monadic at top and over and beside, they all do the same thing. I guess beside could have been different, but that's the original composition in dialog APL, so we can't go back and change that. Whereas I think tiny APL fixes that. So
Yeah.
I can see this making sense, but again, it does require you to be intimately familiar with your compositional operators, which you'll learn in no time, of course, if you use this in anger.
Yeah. Yeah, like this pattern of having dyad after something self does come up fairly frequently, I would say.
Yeah.
So you get used to it.
Interesting. So much food for thought. All right, so we've already, like I said, blown past the hour-and-a-half mark, as per usual, And I guess maybe a last thing, well, two last things, because I've forgotten to bring this up. We haven't talked about the typing mechanism, which is clearly quasi-influenced by Uiua, yet slightly different.
Yes.
And talk to us about that. And then also, is there a rhyme or reason? Because when I first started using this, I could not figure out when to drop the third letter, when to just use the first three letters. There seems to be some differences. So anyways, talk to us about the input method, and are there tips for mastering it quickly?
Yes. So the input method is quite simple. It is influenced by Uiua, but it's simpler than in Uiua. It's less powerful, but it's simpler. And what you have is, rather than having a keyboard, and of course you could have a keyboard, I just prefer Uiua's way, you have each of these symbols having an alias of letters. And if you use the tooltips in the grid where you hover, it tells you equal alias EQ. So if I type in EQ, it formats to the equals function, the glyph. And if I type in equal, that's just going to be an error. It only works if I type in exactly EQ. And all of these glyphs have an alias that you can type easily. Like negate, this is a weird one. It's not NEG, it's NG. But the main thing is that every single function has one. So if you learn all of the aliases, then you can easily type them.
Wait, some have two, right?
Do some have two? I don't think so. Oh, negate has two.
Yeah.
That's the only one with two, I think.
Okay,
Negate you can
because it's
type
so
into
common.
backtick or NG. I didn't like that because backtick is easier, but people have dead keys sometimes on backtick, so it's just for those people it's easier.
And is there a method to the alias? Because that was the part that, like, for pair it's par, but then for a lot of them it's the first three letters. Is there do you just have to memorize them for when it's not the
Maybe
first?
I should change it to PAI. I don't know. It's kind of random. There's no.
Yeah, even sort up is SRU. I'm not really sure.
Oh yeah. Grade up is GRU. Yeah.
And have you made sure that there aren't
Down
any
is
like
GERD.
prefixes, suffixes that clash with each other?
Self is
Like,
SLF. You know.
Yeah, could it be like you don't have to write spaces between these, right?
No.
So how do you make sure that you don't clash?
It's that is a good question, and there are some cases that clash, like pi and pick.
Oh yeah.
Where's pick? Pick is PIC, pi is PI. So it just has to do it greedily, basically. If you write pi, PI, PIC, it formats to pi pick, but if you write PIC, PI, it formats to pick pi. So yeah, it's greedy.
Okay, but that's hard to.
Like that.
Is there anything that begins with a C? That's the first question.
Oh, PI.
Yeah, the
I think
cell.
it would just
So if
parse as PIC. Yeah, if you write PICL, it errors.
Yeah, so this one is unambiguous
with the semicolon.
Oh,
semicolon, it just formats to nothing.
Oh, I see. Okay, it's less than nothing. It's not like nothing in BQN. It's like nothing.
No, literally, it formats to nothing.
But you could also write a space in between, right? Wouldn't that do the same thing?
Yes, you can write a space, but if you don't want there to be a space in the output, then.
Oh, right. I see that survives. Yeah, it doesn't reformat it, so to say. Okay, so it's greedy,
it's not really
not
a
clever.
formatter in the Uiua sense, because all it does is fix the aliases.
All right, so there we've got
Uiua's formatter is much more advanced.
Yeah, the Uiua one. And, if I add this to array box at some point, then, poof, you just control space. You won't have to memorize the aliases. But so as a final question, we have talked about a ton of the glyphs before, after, table or outer product, transpose, reverse, iota. Are there? I mean, we haven't talked about them all though. So I said we could go through them rapid fire, but maybe. It's not very meaningful to talk about the comparison glyphs, which are like the first 6. Are there any glyphs or primitives that you want to highlight? I mean, we haven't talked about sort up, sort down. They were just mentioned, but they either borrow from Tiny Apple.
Tiny APL,
yeah. As very close to the desired sort glyphs that Adam wants for Dialog APL. Not identical, but closer than what BQN and APL. They're the less than, greater than, but with triangles instead of the less than.
You could sort of argue against that, right? Saying, do I really desire more overloading of magnetic dyadic type thing after seeing Fix APL? But I also desire not adding too many glyphs. So
yeah.
Well, I mean, you're already in Dialog APL land. It's not like you're getting rid of ambivalence at this point.
And these sorting functions are sort of only partially implemented right now because they only support sorting lists of numbers or characters, so they don't have any of the fancy array ordering stuff BQN has yet.
Mm-hmm. Any other favorite glyphs that are worth bringing up though?
Transpose is interesting. What was
transpose? I just stole it from Uiua.
I don't know what it does in Uiua, because there are two different magnetic transpose can do two couple of different things on high rank arrays.
It does. I can show you. If I do, okay,
so it does a one
reshape 0.
Yeah, it does a one rotate of the shape.
Yeah,
like
if we do shape,
right.
So as you can see, the shape of transposing a shape 234 goes to 342.
But you don't have a generalized transpose then, right? But you haven't reordered.
No, I probably will add it, but I haven't.
Because if you are depending on the rank and transpose to do anything, since you don't have like access modifiers and things, you really need a generalized transpose. Otherwise, it gets really tricky. You have to use lots and lots of transposes. You can do it without it,
with like transpose cells and stuff.
Yes, you could. Well, there's not enough. You would have to have transpose rank, but then you have to do multiple transposes too. If you want an arbitrary order of the
then you need multiple transposes.
You have multiple transposes, and each time you have to first move things to the end, and then
it's not perfect. It's a rare case, but yeah,
but it can happen.
It can happen, yeah. There's definitely cases where you have like transpose. You know, it comes up, especially because I don't have reverses.
You've got the reshape. So
yeah,
Jay has a fancy reshape, and Marshall went for the simple APL reshape, and then he regretted doing that. But I don't know if you've had any thoughts about that. No, it seems you have the APL.
I don't know what I did. It just cycles it. Like
but that's the point. Is reshape?
It just
reshape has an implicit ravel or flatten or whatever you call it, right?
Yeah,
it always flattens its right argument before it reshapes. Whereas in J, it doesn't do that. It works on cells.
Yes.
So if you do like a 2x2 reshape on a 2x2, then you would get 2x2x2x2 in J, but not in APL.
And I do like that. I thought it was cool. It's complicated, basically. It's not that hard. I guess I could implement it. I feel like you can do similar stuff by just enclosing it and then merging it, though. So
you can do that. J sort of tries to avoid having to do that kind of thing, but it's a classic APL pattern. What does the fix function do? The diamond.
So I just added it yesterday. So maybe I can talk about these 4 functions. They're pretty simple, but they have a nice relationship. So the squares enclose I got that from Uiua, which uses the square for box, because enclosing and boxing are very similar. Then this diamond is called Fix. I'm planning to rename it probably. That's just what Uiua calls it. It just adds a leading one axis to an array.
Okay, I see. It's promote.
I might call
that.
it promote. Yeah, is that the more normal term?
I
Promote?
mean, it's a sort of a new concept to do that, but I think I came up with the name promote and demote because we was talking about rank. So increasing the rank is a promotion.
Yeah. So maybe I'll call it promote. I'm not sure. Currently, it's called Fix. And then this one is pair, which makes a list of the two, I think. And the diamond with the line through it is couple. Let me double check that I have that right. Yeah, the diamond is couple, which
Okay, I see.
rather
That's
than
very
making,
clever.
yeah,
I
rather
like
than
that.
yes, I was quite proud of
So-
myself. I just thought of this yesterday.
So this is not something you got from Uiua, no?
No, well, it's inspired by Uiua, but it's not quite the same. So Uiua but also uses these two symbols, but they don't have quite the same relationship.
Right. No, this is beautiful, right? Connor, you getting this?
No, the insight you had before
Okay.
the
Yeah,
explanation was done.
The idea is
listen,
it's a
let me
table.
explain this.
Yeah.
That the boxing one, right, adds a level of nesting if you want.
Mm-hmm.
And if you turn it 90 degrees, so you get the diamond shape, it doesn't add a level of nesting, it adds a level of axis of
Yes.
outer dimensions. And if you add a horizontal bar on it, then it does that to the argument, but stacking things on top of each other onto the argument. So it's like an over. They are the same thing as catenate over the unbarred version, right? If I understand right.
Just about, yeah.
Yeah, so if you write catenate over box.
Yeah, pair is it puts the two in a list, and couple puts the two it puts the two in an array together with a two axis in front.
But that's the same thing, right? So
but it's not a list because it's not it's what you said basically.
I think
it's catenate over that, yeah.
I'm just trying it out here. Yeah, okay, there it is. Yeah. So if you write at the it's kind of the bottom left one. So the we call it pair. Pair is catenate over box, and couple is catenate over fix or whatever. Promote. That's a beautiful relationship in the visuals of it. I really like that. Because I
was very
pleased
to find out that this diamond with the line through it is in the font. Apparently, Madeline. I'm using Tiny Apple 386 for this, so apparently Madeline added it for strawberry, which I don't know if it's used yet, but yeah.
Yeah, so it bothered me in BQN's choice of glyphs that it doesn't really like for the couple one. It's just like two bows, kind of like the stranding bow, but two of them opposite each other, and then it uses the butterfly symbol for the enlist, and it doesn't really tell me what's what. They sort of do the same thing. But this was really nice. And we can remember that the enclosing is boxing, or you don't have to call it enclosed, you just call it box. Jay calls it box, Sharp APL calls it box.
Yeah.
And you put it in a box, looks like
you want.
And then if boxing sort of turned on its side, it is increasing rank, and you can sort of see the
It also has a relationship to the array notation where you use the square braces, you have higher rank, and when you use the diamond braces, you have the list. Although it's a little inverted, but it is connected to that also.
That would be the opposite. I mean,
yeah, it's a bit inverted, but it's I don't know. I guess in a perfect world it would be different, but I like the square being boxed, so I don't want to change it.
That's it. Yeah, me too. But you might change the array notation instead.
Yeah, I guess I could change the array notation. That would work. Although it would be weird to have Fix APL be the only array notation to have the square and the diamond one swapped.
I mean, if I could start over with everything, then I think I would use square brackets for lists, because that would make it a superset of JSON.
Yeah, true.
If you're using anyway, like
that would be
BQN
better.
uses comma uses a comma for separators between the elements, then it would really be like JSON, and a lot of JSON would be valid.
It does use comma here for this, yeah.
Yeah, so that would be a good argument. Now, is it a good idea to use square brackets for like JSON does or JavaScript does it? Maybe not, but pragmatically, with the way the world is today, that's sort of nice.
Yeah.
And then it would fit
Maybe
with
I'll
the
think
language.
about it. Yeah, maybe I should.
Well, so
It's
yeah,
really
I mean,
cute.
that's a great thing to. Final question is, what are the plans? I mean, obviously you're still making changes, but like, what's your grand plan? Is this going to take over, unseat all the other array languages and one array language to rule them all, or are you just gonna? I assume you're still in school, so you got to
I
finish
am
that
still
too.
in school. Yeah, yeah. I don't think I have the time or the budget to do something like that. But I do quite like this as a foundation. I don't think I'm gonna keep expanding it, making it better. Like, for example, one thing I really want to do is currently you can only use it on this website. So I want to add a version that you can run locally on your computer also.
Mm-hmm.
And adding documentation, things like that. But I don't know. I mean, I do have some plans to eventually make another array language with fixed arity, but with left to right actually instead of right to left, and it's quite different from Fix APL. I don't want to say too much because I feel like whatever I say is going to change, but I've been thinking about making another one for even before I made Fix APL. So I don't know, but it would take a lot longer.
Any advice for folks out there, that are budding programming language designers that don't have the confidence that you had to start your own and put it out in the world?
Do I have any advice? I don't know. I guess I would say just start. I don't know. Start with something small, maybe, and then the smaller you start with, keep starting over and building on. I'm not sure I'm the if I have all of the expertise perhaps to be giving all this advice. I mean, I made the language, but I don't have 20 years of experience.
I don't think you need 20 years of experience.
Only started coding a few years ago. I'm 17,
Well, I mean, I think it's so impressive what you've done. If I was 17 years old and had an array language like this, and the thing is, I think the most really impressive part of it is that you've explored like a new space. Like, I've been talking about a fixed arity like APL for I don't know however long, and I was just reading the other day. I think it was because it was on your site that you had a link to Marshall's complaints about ambivalence. And
yeah.
the ambivalence
I've also got a link to
discussion.
example.com here.
Yeah, it comes up all the time. Like, literally just last ArrayCast, we were chatting about, readability and is it the number of glyphs in Tiny Apple or etc. Anyways, and so when I discovered Jelly, I thought to myself, like, oh, what we really need. Oh, there goes Adam. He may or may not be back. But that when I discovered Jelly, my first thought was like, how come there hasn't been like a APL like glyph language that kind of explores this space? Because it is a very interesting tacit model, right? Just having fixed arity and then dispatching based on the pattern. And then I guess, you've taken influence from a ton of languages. But I love it. Like, I loved it when I discovered Cap, when I discovered Tiny Apple, when I discovered Uiua. It's always just so exciting, especially when it's like a new space is explored, because then, the other languages get to see, what falls out of this design. And even in the comments, I saw Kai said that they were going to incorporate something into their documentation just based on this conversation. Anyways, it's just
Yeah, that's
fantastic.
funny.
So anyways, you're saying I don't have 20 years of experience, and you also haven't even been alive that long. But I just think it's awesome that you've done this project. I really hope that you continue to explore this stuff. Very excited to see you're already similar to Madeline. You're already thinking about a second array language. And
Yes.
it's going to be awesome. In the future, we're going to have like 20 different array languages, all with different trade-offs. So I guess, the last thing is folks can check this out. I believe the URL is netlify.
FixAPL.netlify.app.
Okay. And the
and
docs.
there's also a GitHub repository.
Okay, yeah. And this does have, like you said, it has minimal docs, not for everything. But
yes, there are docs on the readme.md.
Mm-hmm.
There are docs for some of the functions, but not all of them. There's a lot of missing stuff, especially the modifiers. So I'll work on that in the coming however much time it takes me. I don't know. Eventually. I've already got the foundation of the UI, but
yeah, I mean, being able to play around it arguably is it more important? It gives people the ability like me. Like I was already messing around with it and discovering stuff. And
I've tried a dozen languages with zero documentation. Yeah.
Yeah. I mean, and you've got the source, Did I go read the source? No, but you can go ask a tool to go parse it and answer questions.
Yeah, or ask me, I'm happy to.
Oh yeah, what's the best? I assume you're on the Apple Discord?
Yeah, I'm on Discord at jacob.abc. I'm also on. You can DM me or you can message me in the Uiua server or in the APL farm server, whatever works. Yeah.
Awesome.
If you have any questions.
I'm not sure if you can link to a specific user, but if I can, I'll find a way to put those in the description or the show notes. Thank you so much for coming on.
It's also
Jacob.
on the website. Yeah, no problem.
This has been.
I was very happy to talk about it. This has been a lot of fun.
Okay, wait, we're letting Adam.
Oh,
he's been kicked out.
Is he coming back?
Add people. Oh. Admit one guest. We're doing it all live, folks. I see he was blocked out. All right, we were just wrapping up, Adam. We were saying thanks for coming on. We're giving people links to try out Fix APL and links to reach Jacob. Any final words from you, Adam? Sorry, you missed my whole ramble. I guess you can catch it in post.
No, I could hear you all right. I just turned it on YouTube, but I couldn't get back in because Google decided in their wisdom that I needed to something might have changed in my user account, and therefore I need to be asked for permission to continue. So, hooray for that!
I'm not sure what that was. What the hell? Okay, I was just trying to. I'm not sure what was happening with the screen. I was just trying to show a little Mandelbrot set example I added to the website. There's also a Sierpinski triangle here.
Every new language has got the in-REPL graphics now. It's I gotta add that to ArrayBox. Someone commented there. They tried to do some plotting thing, and they were like, "This is table stakes."
We should add this to not just to TriAPL, but also to our main ID as well.
Yeah, maybe.
It can't be that hard. In fact, I think we don't have to add that to it. I think I can just write some library that you can just plop in and it would work. Not right. Actually, I have some more questions about the primitives, but I guess we shouldn't take more time with that because there are lots of other primitives but I'll have to go look at what is documented and
we'll definitely have Jacob. We'll have you back. Also, too, I mean, we can just bring Adam on if you want when we have you on Tacit Talk. And also, too, I'm not sure if people remember. We said we were going to do like 4 or 5 episodes of just Adam and I, getting the process of rolling these out. And then Madeline mentioned Fix APL, and then I went and checked it out, and then I messaged Adam. I was like, should we have a guest on? I need to talk to Jacob about Fix APL. And so then we threw that out the window. Arguably, it would have been a better idea to wait till we had a couple more people, a larger panel, and, I didn't have to put half of the questions on my back and just ended up being confused the whole time. If Marshall was here, I'm sure it would have been Marshall, Jacob, and Adam going, boo, 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 and then I would have just been like, all right, well, at least they all seem to understand what's going on. But once we put together the larger team, we'll have you back, and we can chat more about the primitives. And I'm sure there'll be some new changes since then as well, because it sounds like you're actively working on this. All right. With that, we're supposed to say you can reach us at contact@arraycast.com. I guess also now there's no reason why we can't do the same thing that I do on my other podcasts. I mean, lots of folks have been leaving comments on the YouTube video. Feel free to do that. If you want, though, we might set up GitHub discussions pertaining to each episode. And also, too, thank you for all the folks in the Apple Farm Discord or other mechanisms where people reached out. We had some broken links to past. There was like the show note avenue and technically the episode page were two different things. A couple of those got broken. They're all fixed now. Thank you for pointing and bringing those to our attention. But also, too, now that we have a GitHub Pages website, if you ever find a broken, like a one-off broken link, or you want to even add links that we missed in the show notes, you're able to just go either open an issue or even better, a pull request, and then we'll be happy to just ship that. And this can be more of like a community-driven podcast, I guess, in that sense, because this was not open source before, and now it is. And with that, we can say happy array programming.
Happy array programming. Oh, we have to do this differently. It has to work like this. Like Jacob and I have to say happy array programming.
Jacob was just
are we still on?
Yeah, we're still on. So we have to
on.
say we have to count down
program.
and say it together.
I haven't watched
and then
the podcast in a long time.
when we finish, that's when Connor's supposed to say it. Exactly when you hear array programming.
Oh my!
Then you're supposed to say it, because then it will line up. Because now we know the timing.
I think we just have to give up on that and just, No.
This can work. We just have to
happy array program.
So you should like 3, 2, 1. Happy array
program.
I mean, that sounded pretty good. I mean, it doesn't sound good. That's the problem, Adam. It doesn't sound good for you. But that one actually did sound pretty good on my end.
That was my point. Exactly.
Yeah.
That was my point. We can figure this out. In the course of the next 100 episodes, we'll figure out how to do this.
Every single time, we're just going to be debating on the mechanism on how we wrap the episode.
Exactly.
All right. Thanks, everybody in the chat. And we will schedule another one of these in roughly plus or minus 2 weeks. And once again, Jacob, thank you so much.
Yeah, sure. No problem. It was fun to talk about it. Yeah.
Absolutely.